Hello everyone and welcome to another episode of Supplementary Videos. My name is Kasanas. Guys, in the last video we took a look at instantiation and destroying objects. In this video we're going to take a look at methods of moving an object around the screen utilizing code. Alright, let's get started. Okay guys, this is going to be kind of a demonstration video where I go over some ideas with you. I've written the code already and I've already created the object that we're going to take a look at, and we'll go over that code line by line. But really what I want to do in this video is demonstrate a couple of different concepts that we'll be using later on. Particularly, I want to look at the idea of moving an object through code. We've already seen that objects can be moved through forces applied, so gravitational force is applied to our rigid body, and the object is forced down as long as it's dynamic anyway. The rigid body is dynamic; it'll be forced down through gravity. And I say down, but whatever direction you set up your gravity to go is the direction it'll move. Well, what if we wanted to actually have something else influence, some other forces or some other ability to influence the direction an object's moving? Let's take a look at the object I've created here. I've got this knight's head, and we're going to keep using the knight's head, I guess. It is a really simple object. What I've got here is my sprite renderer, which we know. I've got a rigid body. It's currently set up to be a dynamic rigid body, so it's going to be able to be affected by forces. I've got myself a collider. And I've got myself a script that I called demo movement. And that's all that's kind of on this right now. The demo movement script is going to allow me to introduce to you 3 different methods of moving an object about. Either through translation, so physically moving the object's position, changing the object's position along to make it move in some way. Through the application of force, so by applying forces to an object, we can have that object be moved just like gravity, but we apply our own forces. The third option we're going to take a look at is velocity. So those are the 3. So literally changing the velocity of our rigid body. Right now, if I hit play, our rigid body has a velocity of 0. It's not moving in any direction for any reason because it's sitting on this platform that has a collider on it. My head has a collider on it, so they're just kind of sitting together. So I'm not going to have any velocity at all, but by simply adjusting the velocity directly of the rigid body, I'm going to be able to move this object along. And then the last thing we're going to take a look at is the different types of forces we can apply. All right, so that's kind of what our plan is right now. Let me drag the code over so we can see what we've done here. Now, in the case of translation, that's the one we're going to take a look at first, translation. In the case of translation, as long as you are changing the object's position in some way, you're going to get this translational movement within the object. If I increase the x value over time or the y value over time or whatever value, if I increase or decrease it or I change it in some way, that's going to cause movement. Now, that movement is not based on physics in any way. We are outside of the physics engine at that point in time, and we are literally teleporting the object to its new location. And if we did this, over and over and over again, we could actually produce movement as far as translation is concerned. So let's take a look at the code that I've written here. I've called this particular class demo movement. I have 4 booleans that are public, and this is just going to allow me to turn on one of the options that I want to demonstrate at a given time. I also have created this public float that's going to be the movement speed, so how fast this object or how much force is going to be applied. I've also got this reference to a rigid body, and we haven't discussed this. We will discuss this idea later on, how we go about grabbing this rigid body. I'll go over the code with you right now, but we're going to go in detail about this in a later episode. So for now, just accept the fact that this is going to work. All right. Down in our start function, I have a start and update, a fixed update, excuse me. In my start function, what I do is I find my rigid body using this get component rigid body 2D. Like I said, for now, just accept the fact that this is how this works. It's going to work. It's going to find my rigid body, and then I'll have a reference to it, and I can manipulate the rigid body in some way. We will go in depth into this idea of get component in just a short bit, in a later video. All right, I've got a couple of if statements here. If we are using our velocity, I want it to do something. We'll talk about what that something is later. If we are using our demo force, I want it to do something, and we'll talk about what that thing is later. But for now, we'll go right down here to our fixed update. Inside of our fixed update, so over time, every fixed update, I would like to move using my move translate. I'm assuming we're going to be doing move translate first. I'm going to change the transform's position by creating a brand new vector that changes by the movement speed. All right, so it's going to change the x value over time by the movement speed. I am multiplying the move speed by this time.delta time, and basically what that does is it decreases how often, how large the movements are. So delta time is basically looking at the difference in time since the last update. And what this is going to allow is me to reduce how much movement. Because this is happening in my update and my computer is pretty beefy, if I left it without this time.delta time, this thing would just fly off the screen. We'd never see it again. So by multiplying the move speed by time.delta time, I'm getting small increments of movement that's going to allow it to move slowly over time. All right, and then I just leave it in its transform position and transform Z position. So neither of those two are changing over time. Okay. All right. So that's all the code that we really need to see for now. We're going to take a look at this move force later on and see how that works. But for now, know that all we're doing is translating our object over time. Let's move this out of the way. With my knight head selected, I'm going to click on, go all the way down here, and I'm going to click on our move translate so we can see how this works operationally. I'm going to hit play. All right, and you can see that over time that object simply moves away. I'll hit it one more time. You'll note that because we didn't change over time, we're not changing the actual x and y value. Whatever the x and y value is, it's staying the same. We're not adjusting it. Sorry, the y and z value. The only thing we're adjusting is our x value, so this is going to move along in this direction. It's going to fall off space where it is taken over by gravity. If we watch it one more time, we can see that it is a consistent movement. It is being moved at a consistent rate over time. There's no speed up, no change at all. All right. Why would you use the translation of an object to move that object? If you want it to work outside of physics, it's a perfectly fine option to utilize translation to move the object. But again, remember that it is a small teleport. It's a teleport. And again, it could be a large amount or a small amount, but it's a teleportation. This object is literally moved from one location to the next. It's not moved in an analog manner. It's very discrete. I'm moving from this location to this location, and that's exactly how that works. Let's take a look now at the option for our force. So in a very similar manner, and you saw how we had to do it over time with our fixed update for our translation. In a very similar manner, if I choose the move force by force, I'm going to be applying a new force to our object. And unlike translation, in this particular case, we actually require the rigid body. We're going to be applying a force to the rigid body. So this in the start function where we actually grabbed on and found this rigid body, we're now going to be using that rigid body itself to apply a force. All right, we'll be applying a force to the rigid body, and that's what's going to move our object along. We're going to come outside of our start. We're not using any of this right now. We're going to come down here to our fixed update. Now, once again, we're utilizing the fixed update to apply the force over time. We're going to talk about a couple of different options for the use of force. But for now, just know that I want to apply force over time. So if we are not using move translate, if we're actually using move force instead, I'm going to be using the add force function. So myrb.addForce is going to apply a force to our rigid body. In this particular case, I'm applying the force along a particular vector that has as its x component our move speed. That was the force being applied. And I'm not applying a force in the y or the z. Now, there are a couple of different options to use whenever you have add force. If I add a comma after this, which we'll take a look at in a second, I can use a different type of 2D force mode if I want to. There are two types of force mode. There is the, let me just show you actually, instead of me telling you, there is the force mode 2D.force. This is an application of force that occurs once, and if you want that force to be applied over time continuously, you need to continue to apply that force over time. All right, the other option is the, up here, I can see it right here in this code here, is the impulse mode. Impulse applies a large amount of force, like a gunshot, a large amount of force all at once. It's all being applied at the same time, and boom, this thing shoots off into space. So in our case, for movement, we're going to be using this, the force mode. And if we leave it blank right now, by default, it's going to be using the force mode, the continuous application of force. All right, so inside of my fixed update, I'm doing add force. I'm doing it over and over and over again. So it's continuously adding force to this object. Now, this is going to mean something. Let's take a look. I'm going to move this out of the way, and let's take a look at exactly what that means. I'm going to go down to my Knight's Head again. I'm going to switch it from our translate to our move force, and I'm going to hit play. And watch how this object speeds up over time. All right, force, force, force. And you can see how it's going faster and faster as that force is applied. It is continuously applying force in our code on each fixed update. So every single time with a fixed update, it's applying the force, applying the force, applying the force. That means as force is applied to it, our object already has motion. It's moving along. It's already had a force applied, so our object is already moving along. As we continue to apply that force over and over again, that force builds up and it builds up speed over and over and over. All right. So utilizing the force mode like we have here causes an acceleration to our object over time as we continuously apply forces to it. And again, if I hit play, you can see that other forces continue to act on it. As I apply force to this object, it speeds up and then it falls off. So the gravitational force is still being applied to this object. All right. There is one last thing we're going to take a look at. Well, two actually. One more movement option, and that is by directly manipulating the velocity. Okay, let me drag this over. The last option we're going to take a look at is, once again, adjusting the velocity of the rigid body. So we're going to be utilizing the rigid body once again. The translation does not require a rigid body at all. There's no rigid body required. You can translate that object as much as you want without the rigid body. However, both the options of force and the adjustment of velocity require a rigid body in order to operate properly. So down here inside of our start function, I am looking to see if we have our bool selected, if our velocity is selected. If it does, one time I'm adjusting the velocity. I am saying myrb.linear velocity equals, and I am setting it equal to the movement speed along the x, and the y and the z have 0. So I'm not applying any kind of velocity in the y or the z, only along the x like I've done for the other ones. It doesn't require that we keep resetting the velocity. Once your velocity of your rigid body is set, unless you have something that's slowing it down over time. So let's say I have some kind of dampening, a linear dampening on this object. By setting its velocity, it'll just keep moving in that direction infinitely. It'll never slow down unless I have some type of dampening. A couple of things I should note: that the mass of this object doesn't matter. It doesn't matter if I have a mass of 1 or 1,000. It doesn't matter. The velocity is automatically set to that particular speed. However, when we are talking about the force down here, the force is directly dependent on the mass of the object you have. If I have an object with larger mass, applying a force will not move it as much as an object with a lower mass. So that's really important. The velocity automatically sets the velocity regardless of the mass. It ignores it entirely, whereas the add force command requires you to take a look at the mass of your object that you're applying the force to. More force is required to move a heavier object. Okay, so all we're doing here is we are setting the linear velocity one time, and the object will continue to move at that rate forever as long as we have no dampening. Let's move this out of the way, and let's take a look at our object, our Knight once again. If I actually go down here and I take a look at my object itself, sorry, down here, my rigid body, at the rigid body itself, you can see that I currently have 0 linear dampening, so the object itself will continue to move forever. I'm going to scrub down to the bottom down here. I'm going to turn off my force and I'm going to turn on move velocity, and let's explore it. When I hit play, you'll note that my object has its velocity set, it's rolling along, and it falls off. The velocity does not change. Okay, if I boost that velocity, let's watch this. I'm going to come down here, and in my script, I'm going to change this move speed to a value of 20. Okay, so it's going to go a little faster. It's going to have a velocity of 20, and I hit play. it'll move a little faster. And again, it won't slow down. All right, but you saw how it's moving faster. Let's try adding some linear dampening to our rigid body. If I come in here and I add some linear dampening, let's put it at a value. I don't even know what value. Let's try it at a value of 1 for now and see if that's any good. That might be a little bit of experimentation that occurs here. Linear dampening of 1. You can see how it's slowed down. I'm going to increase my linear dampening a little bit so we can see if we can get to the stop right on our platform. Let's put it at a value of 3, and let's hit play. There we go. So having that linear dampening, that velocity is applied, and then over time, the linear dampening causes this object to come to a stop. The velocity is not maintained. We're not reapplying it. In code, we didn't reapply it over and over again within the update function or the fixed update. If we had, then this linear dampening wouldn't have done anything, right? It would have overcome that linear dampening by continuously resetting the velocity to a particular value. I'm going to put this back to 0, and I'm going to go down to the bottom here, and I'm going to reset my force to 10 so we can explore something else. So that is how those 3 different things move. Again, why would you want to use velocity over add force? There might be a number of different reasons depending on the type of gameplay you're creating. Setting the velocity, it makes instantaneous changes. So as soon as I set my velocity, the object is going in a different direction. So if I have my object moving to the right, because I've given it a positive velocity to the x direction, positive x direction, and then I change my velocity through code to negative value in the x direction, it will instantaneously change direction. So I'll move back and forth instantaneously. If I'm pressing a button one way later on, if I'm moving this thing with buttons, let's say, I'm pressing the A button, it's going to move in the negative direction. If I press the D button, it's going to instantly move in the opposite direction to the positive value. With the application of force, that's not true. With the application of force, you have to overcome the forces that have been applied over time. So if I've applied force by hitting the A button and it's moving in the negative direction, and then I press the D button and I hold it down so I'm applying a force in the opposite direction, the object is going to continue drifting towards the A for a little bit, and then as it overcomes the force, it will then move in the opposite direction, but it has to overcome the forces that have been applied already. Okay, so utilizing the force option can give you some drift that's going to occur. The controls will not be as spontaneous, or sorry, it won't be as immediate. It won't immediately take effect. It might, depending, of course, how you've coded this, depending on how much linear dampening. All of this stuff has to kind of be applied when you're going ahead and creating yourself a moving character. A character that's being moved through input from a player, which is what we're going to take a look at in the next video, actually. All right, guys, there's one last thing we're going to take a look at, and that is the application of an impulse force. Let me just drag this over. So the last thing is this idea of an impulse force. Now, once again, I have a public bool that says apply a particular force. And what I've done is down here in the start, I've applied an impulse force. If that option's selected, I will apply an impulse force, again, using the add force command. This is an identical function to what we used previously to add force to move the character. So in this particular case, it's going to add a force in the up direction, so in the Y direction. All right, so in the Y direction, it's going to add a force of 10 or 20, whatever we had it set to. Okay, it's going to be applied as an impulse, so that's going to be like a gunshot. If you pull the trigger on a gun and that thing shoots out with a maximum amount of force, that's how it's going to be applied. And once again, because I've applied it in the positive Y direction, it has to overcome gravity. So we already have a gravitational force that's pushing down on our object. It has to overcome that gravity in order to move up in the air. And if it overcomes that gravity, it'll slowly slow down as I force it in the air. Gravity force will be acting downwards on it consistently. It'll slow the object down, and that object then will move in the opposite direction once the impulse force has been overcome. Okay, so let me file save this. I don't know why it's saying I didn't save it, but let's file save this. Move it out of the way. And I'm going to scrub down here, and I'm going to turn off velocity for now and turn on demo force. I think a value of 10 is okay. Let's hit play and find out. There we go. We saw it go up and down. Actually, I'm going to add a little bit more force to it for now. Let's add it to a value of, let's say, 20, just so we can see a little bit more force. Obviously, the more force I apply, the higher it's going to go. So let's put it at 20 for now, and I'll hit play. And you'll see it jump up in the air, slow down, and then come back down. Boom, boom. All right. hit it play again, up in the air, come back down. Boom, boom. All right, I just want to demonstrate one last thing before we call it an end of this video. I'm going to put this value back down to a value of 10, and we're going to see how having both the demo force, so forces applied in different directions, do not affect each other. So I'm going to apply a demo force. That's the one that goes upwards, and let's apply air velocity. I can apply velocity or our move force. It doesn't really matter which one we choose. I'll choose velocity for now. You're going to see this object jump in the air like this while it continues in the x direction, and it's going to move along as far as the velocity allows it. All right, so let me hit play. You can see how these things all kind of work independently. There we go. We had that little jump in the air as it rolled off, and it'll work exactly the same way with the application of force. So if I turn off, whichever one of these I pick, I'll just do one last one before we end it here. I'll do the move force. If I hit play, it's going to have forces applied in several different directions along the right by gravity and by our continuous force acting on our fixed update. All right, guys, I hope you enjoyed that. I hope you understand why you might use all of these different options as far as moving a character around. In the next video, we're going to take a look at applying one of these ideas with input to allow us to control a character. All right, everyone, I hope you enjoyed it. If you did, let me know down below with a thumbs up. If you didn't like it, a thumbs down is perfectly fine. Let me know that too. I'm always interested in helping people out there, so if I'm doing something wrong or if I'm doing something right, then please let me know. All right, guys, thumbs up, thumbs down, comments down below, and if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.